what's the probability that you lose? 5, 6. 5, 6. So let's make a little chart here. This is going to be number of die. And this is going to be lose, and this is win. If we roll 1 die, our probability of losing is 5, 6. And our probability of winning is 1/6. Now what about if I roll 2 dice? How do you lose if you roll 2 dice? What's got to be true about this one? Okay, none of these can be 6, and none of these can be 6. What's the probability that none of these are 6? How about this one? 5, 6. And she used a fancy word a while ago for a 10th grader. 5, 6. 5, 6. 5, 6 times 5, 6 is what? 25, 36. And see, I'm just going to have to digress here for a moment. Remember, this wouldn't have been our first day in probability land in a classroom. If that were 25, 36, if that's the probability you lose, what's the probability you win? Whatever's left from 1, so 1 minus 25, 36 is 11, 36. Now notice some of you a while ago when I first asked about what would happen, you said, oh, it'll double our chances. And it almost did. Because if that had been 1236, that would have been 26. That would have been double your chances, but it didn't quite double. Now I'd like for you to work with your partner to find out exactly, theoretically, what the probability would be for winning if you roll 3 dice or 4 dice. 3 dice or 4 dice. You are just throwing stuff everywhere today. You did.
Sorry.
Throwing dice, throwing stuff. It's just crazy.
I didn't even know I did it.
So and you have your calculator there. If the numbers are intimidating, you're fine. So, would you please give me your lose and win for the 3 line here, please? 125 over 216, so that made the win be 91 over 216. All right, and how about the 4th line? Go ahead, I'll let you do that since you got it.
625
over 1296, so the winning percentage is
625.
671 over
671 over 1296. Okay, and if you take your calculator and you do 671 divided by 1,296 and you get a decimal, It's a little more than what? A little more than half. It's about what percentage? Okay, so about 52%. So you got a little better than even chance of winning there. Now I want you to think and generalize, and then we're going to do something really special with your calculator there. I want you to think about how each of these came to be. This was 5/6. What's a fancy name for 25/36? 5/6 squared. And this is 5/6 cubed. So now I want everybody to think about, and let's try to do this by yourself. This is 5/6, 5/6 squared, 5/6 cubed. Suppose we had X dice. X dice. Think about what the probability you'd lose would be. Write it down. And then right over beside it what the probability that you would win would be. I guess the projector turns off after so long if we just abuse it. All right, now, when you get your formula for win, compare it with your partner, see if you agree that that is the formula that it is. And I'd like for you to type that formula in to the Y1 line of your calculator. Agree with your partner about what the formula is, and let's type that in there. Did y'all agree? I'm not going to fight over it. Good. Okay. Y'all were in agreement? Okay. Excellent.
You want winning, right?
Say again.
You want the winning, right?
Yeah, the probability of winning.
That's really exciting.
All right, and through the miracles of modern technology, we're going to kind of compare notes here. As I've looked around, I believe we're pretty much in agreement that the formula is 1 minus 5/6 raised to the x. That should be the winning probability. So I have that typed into Y1. Let's generate a table now. So if you'll look on your calculator on this top row, notice that you have, as one of your choices, table. And it's in blue above that top right-hand key. So what I'd like for you to do is I'd like for you to click second and then table. And we should have a table there that looks a lot like what we have on the board, only it's in decimal form. So the probability of winning when we roll 4 dice, remember what you said, was about 52%. What does that decimal look like? You've probably seen that decimal almost before. That's about what fraction? 0.665. It's close to 2/3. So you get about a 2/3 chance of winning. Scroll down and tell me how many dice you'd have to roll to be at least 90% sure that you'd win. Just scroll down to your table. All right, now she said 13. And notice if I scroll down through here, when I get to 12, mine just keeps on going. It has a life of its own. When you get to 12, you're not quite to 90%. But when you get to 13, there's a 90% chance. And the number continues to climb, but I like, going back to what you said, that these are getting smaller and smaller, those differences are. Let's look at a graph. I want you to go to that top line where it says window, and let's set a really intelligent window. Now, your calculator, because I set every one of them before you got here, I just put it on the standard -10 to 10 window. So let's talk about what makes sense here. In this problem, what does X represent? The number of die that you have, which couldn't ever be any less than, really, 1, but we'll